Good morning. Myself P. Revati from Department of IT, Hindustan College of Engineering and Technology. Going to share the content on microcontroller and embedded systems. In this video, I am going to elaborate the pin diagram of 8051 microcontroller. Coming to the contents, we are going to discuss about the pin diagram and pin configurations. The microcontroller 8051 was designed by Intel in 1981. It is an 8-bit microcontroller. It is built with 40 pins dual inline package. So one side you having the 20 pins, another side having 20 pins, and 4 KB of the ROM storage and 128 bytes of the RAM storage and two 16-bit timers. Here 4 ports will be present: port 0, port 1, port 2, port 3. Now let us see each and every pins clearly. Coming to port 0, the port 0 is characterized by two functions. One is when the external memory is used, then the lower address byte, that is addresses A0 to A7 is applied on it, else all bits of these ports are configured as input output. The next one is when P0 port is configured as an output. Then other ports consisting of pins with built-in pull-up resistors connected by its N to 5 voltage power supply. The pin of this port have this resistors left out. Coming to next port, port 1. Port 1 is a true input output port as it does not have any alternative functions as in port 0. But this port can be configured as general input output only. It has a built-in pull-up resistors and it is completely compatible with TTL circuits. TTL stands for transistor logic circuits. Coming to port 2 is similar to port 0. When the external memory is used, pins of this port occupy addresses intended for the external memory chips. This port can be used for higher address bytes with addresses A8 to A15. When no memory is added, then this port can be used as a general input-output port, similar to the port 1. Next port is port 3. In this port, the functions are similar to other ports, except that the logic 1 must be applied to appropriate bit of the P3 registers. So first take 1 to 8 pins. These pins are known as port 1. This port does not serve any other functions. It is internally built up bidirectional input-output ports. Just it acts as the input-output ports. Other than that, it cannot do any other functions. Now coming to the next pin, that is pin number 9. So what is the use of pin 9 RST? RST is nothing but reset pin, which is used to reset the microcontroller to initial value. That means if microcontroller performing the some task. For example, after execution of the one cycle or the one program, it should reset the initial values. That means all values should get 0, 0, 0, 0. The one more time it will start executing the programs. That is we call this a reset. That means it come back to initial positions and again it will start for the next execution cycles. So for that purpose reset pin can be used. If reset is a high, it will reset the microcontroller. If reset is a low, it will work accordingly. Now coming to the next pin 10 to 17. The pin number 10 to 17 can be used for different work like interrupts, timer, input, control signals, serial communication signals, that is a receiver and transmitters. The pin INT0 and INT1 stands for the interrupt 0 and interrupt 1. The next pin is T0 and T1. It stands for the timer 0 and timer 1. The next pin is WR bar. It stands for the right bar. Whenever it is a low, this pin will take as a high. And if right is equal to 1, that is equal to high, that means the device which is connected, that is ready to write, the document can be edited. Whenever it is a high, the write operations cannot be executed. The next pin is RD bar. It stands for the read operations. These read operations can be taken at port 3.7. Then you have RxD and TxD. Microcontroller can receive the signals and can transmit the signals. RxD stands for the receiver and TxD stands for the transmitters. Now coming to 18th pin, here 18th and 19th you can see the pins are used for interfacing external crystals to get the system clock. The external crystals will be connected to these two pins so that it can get the system clock. The next pin is 20. This pins provide the ground to the circuits. Then coming to the next pins 21 to 28. These pins are known as port 2. It serves as an input-output port. Higher order address bus signals are also multiplexed using this port. The next pin is pin number 29. This is PSEN pin, which stands for Program Store Enable. It is used to read a signal from the external program memory. Now coming to 30th pin. This is the EA pin, which stands for External Access Input. It is used to enable or disable the external memory interfacings. The next pin is 31. This is the ALE pin, which stands for Address Latch Enable. It is used to demultiplex the address and data signals of ports. Now coming to this pin 32 to 39. These pins are known as the port 0. It is act as the input-output port. The lower order address and data signals are multiplexed using this port. So this pin number 32 to 38, that is the 18 to 87. These 8 pins can be used for address purpose as well as the for data purposes. So they are indicated by AD naught, where D naught stands for the data bus. Whenever it is performing actions on the data bus, it will use as D naught to D7. Otherwise, it can be used for address bus. So AD0 to AD7 is nothing but address and data bus. The last pin 40, that is a VCC, plus 5 voltage supply can be given to the microcontroller. So the chip will be active. This is the pin descriptions of 8051 microcontroller, where the 8051 microcontroller is type of the microcontroller. Thank you.